All right, this is Prelab Part 2. If you want to pull a stool here and there, you can sit down, okay, if you have problems with your feet or whatever. This is going to be Prelab Part 2. Let's understand, the first thing is that these are goggles and they have to be worn, okay? They have to be worn. All right, so they're actually pretty good. These are pretty good goggles actually. You know, these are like almost like as good as really good skiing goggles. They're pretty good. All right, now where I want to get to is this setup. Okay, these are crucible tongs. See them? See how they're the shape of them? There's different types of tongs for picking up scientific glassware. These are specifically crucible tongs. You see this little circle here? Very nice circle. You can go like this. Pick it up like that. Yes? You can take the top. This is called a crucible. Comes with a complete with a cap. Okay? There's a crucible. Yes? In this crucible I have magnesium that I have masked out. Okay, that's where I want to get to. Clear? Here's a Bunsen burner. Okay, and what I'm going to do is first thing I'm going to do is I'm going to fire this up. Okay, now it's important for you to look at all of the pre-labs. This is what I do. I do pre-labs for every lab and I film them, and it's important for you to look at all the pre-labs because I go over safety protocols. First of all, do you ever hold your hand in a flame? Or?
No.
No, that wouldn't be good, right? Do you ever pick up, if you're heating things and you're heating this, would you ever pick this up while it's hot and try to hand it to somebody? No. No. Maybe if you had leprosy, you wouldn't notice until you could smell burning flesh. I don't know. Who knows? So you're not going to touch any of this while it's hot, right? That's not good, right? Okay. So you're not going to take the burner and kind of like, you know, right? Okay. Burn out your nose hairs. Okay. So this burner, the gas comes out here, comes through, and it comes out here, okay? And there's a little valve here, little valve. You see that? How that lets the Ray, thank you for participating. You're very good at participation. Excellent. So do you see how there's a little valve here that lets the oxygen in? Well, sometimes there's too much oxygen. You have to close it off a little bit so you get just the right mix. Because it is mixing, remember combustion, a type of chemical reaction? You're mixing, a mixture of hydrocarbons, propane, butane, who knows, maybe a little ethane in there for all we know, maybe a little pentane. There's a mixture of hydrocarbons in here. It's mostly propane, I would gather, or butane. Comes out here, and you're mixing it. So it's going to be O2 plus the hydrocarbon, and that's called combustion. Now, if you look at this carefully, we'll examine nothing that's stuck. There it goes. Okay. We'll examine how to light this burner very quickly. Okay. Okay. Now, do you see that that orange flame there? Could somebody stand by the lights for me? Z-Man, could you go up there and turn the lights off and on as I give you the cue? Okay. I need something black. Here, may I use this? Okay. Can you see that a little better? Yes, a little better. It's actually, I was looking at the, I'll try not to melt things, okay? Whose is this?
Mine.
All right, well, it doesn't matter if I melt. No, not melt. No, sorry. Don't ever do that, by the way. Okay, excellent. So, can you see that a little bit? Okay. So you can see, and don't ever touch the flame. Okay, don't ever touch the flame. Don't ever go like that, okay? Ever. Okay, now, these are actually not real fingers, they're metal replacement fingers, so I can, okay, so anyway, so you can see that that's a dirty part of the flame. This, can you see where the flame is blue?
Yeah.
That's actually the clean part of the flame. If I go like that, that's nice and clean. Do you see that? Yes, you see that? It's nice and clean. That aqua, cyan, blue. You also notice that there's two cones. There's this cone here. You see that cone there? And then there's that cone there. That's the hot part of the flame right there. That's what you want to get. You want to get, thank you for paying attention. Excellent participation. You want to get that double cone there, yeah? And then you actually want to heat, let's say we're boiling water or, you know, heating a crucible. You actually want to put the flame like right there. Right there. You see that? Okay, can we turn the light off, please? So do you see the double cone a little bit more clearly?
Yeah.
There's the top cone. There's the top of the top cone. And then there's the inner cone. Okay, do you see that? Yes? Okay. That's how you want to get it. So watch when I adjust this. I'm gonna get rid of a lot of the oxygen. That means that what that means is that you're giving off a lot of. Oh, I can smell the protein from the back of my hand. Okay, you're giving off a lot of hydrocarbons. You get this incomplete. It's a great word. Incomplete combustion, where instead of producing carbon dioxide and water as your sole products, you're producing some carbon dioxide and water. You're also producing intermediate products. You're producing a lot of hydrocarbon products, or you could be producing some carbon monoxide. You could be producing some weird hydrocarbon compounds. You know, when someone smokes cigarettes, you get this very incomplete combustion, and as a result, you produce like 400 or 500 different chemicals, 40 or 50 of which are carcinogenic. What does the word carcinogenic mean? Anybody know? It means cancer causing. So you get a lot of products from cigarette smoking that are actually carcinogenic. So this is incomplete combustion. So what you want to do is you want to let some oxygen in there so that you burn the hydrocarbon more completely. See that? So when you light the flame, you want to light it closed so it lights. Okay? And then you slowly, with your fingers at the top of the nozzle, not on the nozzle, but on the top of the nozzle, you slowly turn it to introduce oxygen into the mix. And just when it starts to make a noise, when you hear the flame, just when it starts to make a noise, that means there's a little bit too much air in there. So just dial it back to like a millimeter. Hear that? You hear that? Now watch, listen. You dial it back, see? You see that? And that's your flame. You put too much in, it's gonna go out. If you put too much oxygen in there, okay? It might go out, okay? But here what you do is you have it like this, and then you turn it. So you get the double cone and you just start to hear some wind. Turn it back, there you go. You get it? You see what to do? Easy? Okay, can we have the lights on, please? All right, so this is what it looks like with the lights on. Does that make sense? Can you see that? Can you see that? Can you see it a little better? Yeah? So there's the top of the, okay, I'm sorry, that's the top of the flame, that's the inner. Okay, so this is the top of the cone, the top of the inner cone. This is the top of the outer cone. You see that? Okay, you get it? Understood? Okay. Now, let me just turn that off for a minute. And what you're doing is, you're using the triple beam balance to find the mass of the metal. And I'll put a data table on the board to help you do that. All right? Yes, do you get it? Okay. So you're going to put a piece of paper on, you know, like that. Then you're going to tear the paper. What does it mean, tear? What does that mean? Tear weight. What does that mean? And you don't really need the tear weight. In other words, the tear weight is, you just simply adjust this so it's back to 0, but you don't have to do that. Just find a new mass. So you're going to take, it's going to take around 10 centimeters of material. It's going to take about 10 centimeters, I noticed this morning. Okay, so flip your meter stick over, and you're going to take about 10 centimeters. It has to be about, okay? And then you find the mass of this, okay? And it's not going to go up much, okay? So you know, you've got to find the mass of that, okay? So you're going to find the mass of both, and etc. You get it? And it's really not going to change much because the mass of that is very small. You see that? Okay, now, and then you're going to find the mass of this empty. Okay? You're going to find the mass of this empty. Clear? You want the top on it too, because some of the magnesium oxide will crust on the top. Okay? So then you put this on it too. You find the mass of these two things as well. Okay? So you can find the mass of everything together, or just do it separately. However you want to do it, it's fine. Okay? I'm going to leave a little bit creativity up to you. So you're going to find the mass of that, yes? And then you're going to find the mass of this afterwards, right? With all the material in it, etc., and the piece of paper on it, etc. Okay? But can you put this hot on this?
No.
No, you got to let it cool. Cool to the touch. But you don't really want to touch it. This isn't a quantitative analysis lab. You're not in college where you're using 4 decimal places. If you use 4 decimal places, the sweat on your hand could be significant. So you only want to use these. Even if it's cooled, you want to use these. See? Now, as soon as you get your equipment, you want to practice. You want to practice. Because you've never used these before. These are extremely expensive. These are like $10 a piece, man. So you drop that and it's like, you know, expensive. So you want to make sure that you are careful with them. So you want to practice. Lift it up like this. Lift it up like this. Okay, practice. Become comfortable with it. Lift the top up. Okay, you get it? Okay. Some people want to just like go like this, and it's a little weird. Don't do that. You know. Like, get it so you can pick your nose hairs. That's how you do it. You can't pick your nose hairs. It's a little weird. Okay. Okay. So you get it. So it's down. Okay. So then what you do is you're going to put this on here. You're going to put this in here. I'll put the little piece in. And you're going to put the you have the mass of everything. And then you're going to, and I'll tell you what's kind of funny. I made all of these comments about people who don't use triple beam balances, etc. But we're using such small pieces of magnesium, we're going to actually use electronic balances, even though I made this big thing on the first film about using triple beam balances, and that's really all I want to use, okay? And you'll get comfortable with them. But so we're going to use actually electronic balances. But anyway, for today, just for this lab. Okay, now, so let's turn this on, and we're going to cook this. I want to show you how I want to cook it. So you put on the juice. Oops. And you see how this is set vertically? So you want to make sure this is set vertically before you start cooking. Okay? So you have this set. So you see there's the top of the flame, and that's exactly where it's set. You see that? It's the top of the inner cone. Okay? So you leave that on. And now what you're going to have to do, once it gets warm, once it starts to get hot, you're going to want to do this. You're going to want to take this top and put it like that. Let a little oxygen in it, okay? Maybe kind of like go, hello, hooray, okay? You get it? You want to get some oxygen in there so the magnesium can burn. Understood? Yes? Okay, good. I'm going to let this run here. No, I'm not. I'm going to turn it off. Okay, so this has got to cool, even though it was on for just a minute or so. I want it to cool, so don't touch that. So I think we're ready to start the lab, don't you think?
Yeah.
Okay, next time. Because if I started it today, guess what? I'd have 4 or 5 zeros because some people don't have their safety sheets in. So if you don't have your safety sheets in by next time and we start the lab, I don't care if it takes me 4 weeks to finish the lab. If you don't have your safety sheets in at the beginning of the lab, then it's a 0. Understood? Okay. So let's review some of the safety procedures. Do you put your face in a flame?
Nope.
No.
Do you lift up a hot object?
No.
Do you use crucible tongs instead of your fingers?
No. Yes.
Yes.
Z-man?
Yes.
You're not a robot. Okay, excellent. Okay. Do you, if something was labeled acid, it was a liquid in an Erlenmeyer flask or a beaker, and it said acid, would you drink that?
No.
Okay.
No.
If something was labeled water and it was in a scientific beaker in this glass, would you drink it?
No.
No, because you don't know where the beaker's been, quite honestly. Understood? Yeah. So if somebody could have taken a dirty beaker and filled it with water. Okay? Go to the kitchen if you want to drink, okay? T, you all right? Okay. Would you take acid and throw it in somebody's face? Excellent. Okay. Would you take a girl's ponytail and like light it on fire? Okay. Would you throw laboratory equipment across the room at somebody?
No.
No. Excellent. These are great. These are great answers. These are great. Excellent. You must have read the safety sheet. If you get injured, what's the first thing you do? Tell the teacher. Tell me. Okay, or have your partner. Okay. Yes. Understood. What's the thing, Ray? You can see me after class. Thank you. And we're going to talk about your wonderful class participation. I want to honor you with an individual citation. Okay. So we got to do that after class privately. Excellent. I don't want to embarrass you. Now, if however, you became on fire, what would be the most important thing to do? Your lab partner would help you to the shower.
What shower?
Laura, thank you very much for noticing where the shower is. Is it important to know where the eye wash, shower, fire blanket is, do you think? Is that important? Would that be an important thing to know? Excellent, that's pretty important. Excellent. Laura never knew that there was a shower in here, even though she literally walks past it every day, and it's red. Excellent. What else? Have you ever seen eggs frying, like sunny side up? Okay, that's what happens to your eyeball, and you can't really see it when your eyes are exposed to acid. They start to cook. Okay, they start to cook. So if you kind of hang out and delay, if you get any kind of acid in your eyes, and you kind of hang out and delay, you want to finish your thought, you're going to have a cooked eyeball. Just make sure you remember the Tabasco sauce when you serve it to your lab partner. Okay, the last time I had an eyeball was with Tabasco sauce. Okay, so that's really important to do that. Okay, now, so these are, what's my point? Much of safety is what?
Common sense.
Very good, Alex. Common sense. I'm going to hold you to that. I'm going to remind you next time. Now, would you have like run around the classroom and try to catch each other, or no? As soon as it's not running, right? Yeah. And do you wear baggy clothes when you got to get rid of the sweatshirt, big guy? Yeah, you got to get yeah. Your ties. You can't have your ties on when you're in lab. Sorry. You can't have your ties on in lab. That's like the worst. okay? Because those things will go up like a Roman candle. Those are actually organic substances. They're fake and they'll melt. And they're like a wick. They'll go right up and you're the candle. Okay, so there's going to be some screaming students that are on fire running across the classroom. All right? Who's that screaming student that's on fire running across the classroom? That's Laura. Okay, so you've got to be very careful. So end of pre-lab part 2. I think that was good, yeah? Okay, so Kennedy, if you could give us the old, we're off.